welcome. It's good to see you. It's one of these days we'll see you all in person, but for now this is better than not seeing you. So I think these trainings I think are really quite important, and I think that it's one of the challenges of doing evidence-based assessment is that there's evidence and the evidence changes. And it's something that Andrew Harris and I have written about in the past, but I think it's something which is I guess, a challenging part of being a trainer for these instruments. And that there's one thing to understand how to score them. There's one thing, how to, do whatever with them, but to understand how the research affects them and goes forward requires a certain level of fluency in numbers and statistics. And so that book that I've written is, I've sort of talked to you about, is one of the reasons I wrote the book is for you guys, essentially, to help you get up to speed on those things if there's some areas you're not quite so familiar with. And these series of trainings, I've got 3 of them lined up now. I'll probably do a few more in the fall, see what people are interested in. But it's just a way to help us understand what the evidence is, and then to use that to keep the things alive and keep them moving. So once you developed a risk tool, it's good for now, but we may learn things, and we do learn things, and hopefully we learn things. And when we learn things, then we can make things better. And that's what I want to have happen, and I want you guys to participate in that. So so today I'll be talking about criticisms. This is sort of a broad overview, and I'll be talking about some very specific things that people talk about, as well as some more general principles that you need to pay attention to. And the next 2 trainings are more really statistical, where you go through the nuts and bolts of how do you actually calculate some of these some of these statistics. Hopefully we'll have some chance to discuss my material. I'll see how much time we take. Feel free to use the chat. I got the chat open so I can see that. I may not always respond immediately, but also feel free to interrupt. We're a small enough group. Just ask questions if at the time. Okay, so I'm just sort of go through these various criticisms. Okay, the one I'd like to spend a little bit of extra time on is this, what I consider a not so valid criticism, and it is an argument that it is impossible to infer likelihoods for individuals from group data. This argument has been around for a while. It has different forms, but it really came into prominence by the work of David Cook, Steve Hart, and Michie, who wrote a series of papers which basically used, I guess, probably statistical arguments to make this point. Their statistical arguments have been, carefully examined by people who sort of know the statistics and are not found to be particularly interesting. They're, I'd say, creative solutions, which aren't, I guess, don't hold up. But I think that the big point that they're trying to make is actually interesting. And it's more of a philosophical point. And this is where I'm basically coming to. The point they're making is a theoretical, conceptual point, which they're packaging in numbers. Now, I'm going to ignore their numbers, but I'm going to focus on the conceptual point. And that's and I think it's important to do so. So, I partially always thank your critics because they keep you on your toes. But, I wasn't particularly sensitized to these issues prior to these articles, and now I am. And I think, and my goal is to sensitize you to these issues as well. So this is the problem. So you have a risk assessment. Assume you have an actuarial risk assessment, and you have your client, Johnny Knuckles, and he has a particular set of characteristics. He has, say, 3 prior violent offenses, he has negative attitudes towards authority, and he's unemployed. Okay, so these are things that would likely show up on a risk tool of whatever. And then there's a bunch of research studies that have been done, and they found that out of 100 guys with these characteristics at this risk level or with this combination or whatever, that 40 will violently reoffended within 5 years. Okay, so that's a research finding. Now the question, and the question that you as an evaluator are interested in, is what is Mr. Knuckles' likelihood of committing a violent offense within 5 years? Okay. So this is the conceptual statement of the problem. And this is from Sherlock Holmes, a quote by Arthur Conan Doyle in one of his, he says, well, the individual man is an insolvable puzzle. In the aggregate, he becomes a mathematical certainty. You can, for example, never foretell what any man will do, but you can say with precision what average number will add up to. Individuals vary, but the percentages remain constant. So says the statistician. Okay. You should sort of recognize that, because that's a common way of thinking. And then we're stuck with the issue of, well, what is Johnny Knuckles' chance of reoffending? How do we even talk or think about that? And one of the things is that people have different views of the nature of probability. One of the views is that there's a sort of a fundamental deterministic sort of everything is there for a reason. Classic Albert Einstein is, God doesn't play dice with the world. He was specifically commenting on quantum mechanics, where things happen with probabilities inherently. He didn't like it. And this other quote is from Zeilinger, is the counterpoint to that. And it's the discovery that individual events are irreducibly random is probably one of the most significant findings of the 20th century. So the idea that events can happen or not happen, like if you, within quantum mechanics right now, things have a tendency to exist. They'll exist and they disappear with a probability. And that's how that's how they create, and that's how people believe the world itself is existing now. A lot of what I'm talking about is based on or drawn from this book. It's a great book. It's not completely easy reading, but if you are interested in this topic at all, this book was recommended to me by a number of years ago. And it was actually Douglas Mossman recommended it. And I said, yeah, I'll get around to it. But when I got around to reading it, it was great. And so I'll be talking about a lot of what, if you want to know more about it, this would be a place to follow up. So when we use the term probability, it has different meanings, and we should be aware of what these different meanings are. So one of the meanings is certainty of belief, which are referred to as subjective probabilities. So I can say that I'm 90% certain that Victor did it, is doing it, or will do it. So past, present, and future. So if you say I'm 90% certain that Victor will reoffend, you're making a thing about the past. But you could also make a statement that he's 90% certain that Victor did the crime. And from the same conceptual framework, these are the same statements about the past, present, or future. And there are subjective probabilities which have to do with certainty of belief. There's another meaning of probabilities, which are logical, often called classical probabilities for games of chance. So these are given a finite number of possibilities with known frequencies, you can estimate mathematically a probability for in this case. So if you're rolling a dice with 6 sides, and you're trying to get a 6, there's one way of getting a 6. There's 5 ways of not getting a 6. So the odds are 1 to 5, or a probability of 1 out of 6 to get 6. And that's a logical. And if you look at, if you ever seen in professional poker on TV, they can calculate immediately the probabilities. These are logical, classical probabilities from the cards on the table and the cards in the deck. The third meaning, which is closest to our meaning, is stable proportions in nature. So that when you talk about probabilities, the probability that a child will be born a birth male versus a birth female is about 21 to 20. And there's a lot of, this is where Sherlock Holmes was talking, you know, the rates of suicide, the rates of recidivism are all pretty stable in the aggregate. And you find these across different types of phenomena. And when people first saw this, they were quite like this is really interesting. And they started, you know, why they're stable. Why is the suicide rate very stable, you know, in France year after year? And these are what I call, you know, empirical probabilities or stable proportions in nature. Okay, getting sort of one level down. So I'll present 3 like what's called formal theories of probability. These are the types of things that essentially philosophers and mathematicians spend their time thinking and talking about. I wasn't even aware that there were different theories of probability until, you know, fairly recently. So the one that you're probably taught in graduate school is something called the frequentist model. And in the frequentist model, probabilities are mathematical abstractions. Specifically, they're the limits of an infinite series. So if you were talking about what's the probability of a fair coin flipping a heads, it is, if you flip the coin forever, what number of heads would you get? And if it was a fair coin, that number would be, you know, exactly 50%. It is defined as an abstraction based on certain conditions or rules of the game. So given certain rules of the game, you'll end up with certain numbers. And it requires this concept of a repetition of an infinite series. And the frequentists are quite explicit that it does not apply to individual cases. So from the frequentist model, you can't say that somebody's probability is 50%. They're either heads or tails. They're not half a heads or 50%. It doesn't make sense within that conceptual model. And for many people, this was the only model you were taught. Like I got a stack of statistics textbooks from my graduate schools, and almost all of them are based on frequentist. All the p-values you talk about, confidence intervals, almost all of those are within the frequentist model. The second one is the Bayesian model. And these comes back to the subjective probabilities. Here, the probabilities aren't features of nature. They're certainty of belief. They're a judgment. Like, what do I think? How confident am I about what people are like or will do? And from the core concept, it's the I guess the basis of a rational bet. Given all the information you have, what's your best guess about what's going to happen or has happened? There's a third model, which is the propensity model, which is associated with Sir Karl Popper, who's a philosopher of science. And it's a variation of the frequentist model. And he basically believes that probabilities are features of nature and that things have propensities to behave certain ways. And individual things, he would argue, have a propensity. So if you have any particular, things, example he gave had to do with the rate of radioactive decay of, pure radium. And so he was talking about things within quantum mechanics, that individual atoms or aggregates have statistical properties of propensities to do things. But conceptually, it's the same thing if we have propensities of people to do things. people have a propensity which could be quantified by some sort of number. And I think that is closest essentially to the model that we intuitively apply to people. So in terms of how do you make inferences, back to Johnny Knuckles and the group data. So inferences about the future behavior of an individual requires professional judgment. Administering a risk tool, an actuarial risk tool or anything, isn't the risk assessment. It requires some interpretation. And as president of SAARNA, the Society for the Advancement of Actuarial Risk Need Assessment, I strongly believe that group data based on similar individuals provides a very strong basis for making inferences about specific individuals. So that is your best source of information about inferences about an individual, is group data. But it is a professional judgment. It requires judgments concerning the degree of similarity between the case you're looking at and the case at hand, or the data, quality of the data, and I'll talk more about that in a few minutes, and a relevance of the group data to the evaluation. So if you're doing an assessment of somebody, you're interested in domestic violence, recidivism, and you have a VRAG score, which has general violence, does that line up with the types of questions that you're interested in or not? And the same logic applies to risk factors as it does to recidivism rate estimates. The example I give in my book is I was reading a report by I'd say a competent evaluator who was doing a DO assessment. And she, said things like he has, pedophilic interests, which increases his risks. And then she got to the point where she administered a STAC 99 and some other ones, but she said, gave the STAC 99 recidivism rates for the group, but then she said, but it doesn't apply to the individual. Well, I don't know whether it applies to the individual or not, and cited Hart, Cook, and Mitchie. And she could have said, the guy's got deviant sexual interests. Group data shows that deviant sexual interests increase the risks. However, I don't know if it applies to him because he's not the group data. It's exactly the same argument making generalizations about risk factors to an individual for propensities or likelihoods as you would for risk factors. You need somewhat stronger, you need a judgment about the quality of the evidence, but it's the same logical operation. There's nothing incoherent about making statements or using group data to make inferences about individuals. In fact, I think that's the best, very often is the best source of information, not exclusively. So if when you're communicating it, it's perfectly all right to say things like, Mr. Knuckles has a 40% chance of violent recidivism. Mr. Knuckles has it. You could also say, you don't have to say, but you could say he's a member of a group of which there's 100, 40 out of 100 are expected to violently offend. You can say that too. But you can also say Mr. Knuckles does, and that's a judgment that you make as the evaluator. Or the weaker still, 40 out of 100 individuals with a risk score, the same as Mr. Knuckles, violently reoffend, which is a weaker, even weaker statement still. But these are different statements. And if you look at the sort of history of the static, we have tended to sort of land within number 2, essentially. Mr. Knuckles is a member of a group, and it's somewhat, it's defensible, but I think number 1's defensible too. And I think that is something which evaluators can and should do. If the question is, what's Mr. Knuckles' likelihood of reoffending? I don't think you should stop at he's a member of a group. I think you should stop, you should go all the way to Mr. Knuckles. So I'm going to pause right here and see if there's any questions or comments, and then I'll go on to the next section. There's a comment that this is a common line of cross-examination in New South Wales. Well, yeah, I've had it too. So one of the things that you can respond to is you can, for those of you who got chapter 2 of my book, you can sort of take a look at that and it'll give you a way of how to respond. But it's something which people do often bring up, because it comes back to Sherlock Holmes, right? It comes back to that sort of intuitive way of thinking. And it is a way of thinking, and you know, people think that way. But I think we can do better. Yeah, the next question has to do with rounding. Yeah, if you say like 41.26, you know, I don't believe you. You know, so this is again coming up with the next section, is how much confidence in how much precision are the estimates. In many cases, our estimates are they're not to the second decimal point for sure. They're probably, if you round them to tens, like 10, 20, 30, you're probably pretty close. I'm not sure even 42 would be within the precision. We produce some confidence intervals for some of these estimates, and I tend to keep sort of averaging within those confidence intervals. But yeah, again, that's what I actually do. I usually give no decimal points, but I usually give, like if it's 41, I give 42. And then I'd give the range, a plausible range for that. Anything else? Okay. Next, valid criticisms. Okay, there's lots. And what I'm going to do is I'm going to go through the criticisms and just sort of highlight them, and then make a couple of comments about where the, I guess, the static, stable, acute risk tools sort of fall in these ones. One of the criticisms is low predictive accuracy. And what I mean by low is that there's not no. You're not looking at statistical significance. What we're talking about is it's no better than cheap, easier alternatives. And so, you know, unstructured professional judgment is the easiest and cheapest. And it's, in many cases, it works. You know, if you have a guy who's got lots of criminal history and he's always reoffends, you know, he's higher risk. And, you know, you have to do better than that. These are sort of AUC values in the sort of low 0.6s, high 0.59s. Now, one of the things that it's important is to differentiate. There's two features of risk tools which need to be addressed. One is discrimination, or the extent to which recidivists are different from non-recidivists, or relative risk, how much riskier. And then there's calibration, which is the similarity between the expected likelihoods and the observed values in replicated replication studies, or absolute risk. And you need different statistics in order to evaluate different properties. Now, I'm just going to show you a table of, these are different statistics for discrimination and calibration. And so, you know, AUC values, odds ratios, Cox regression, Cohen's d, logistic regression slopes are all discrimination parameters. And calibration, you know, chi-square, EO, meta-analysis of rates, you know, calibration plots, meta-analysis of these zeros in the. Now, next up, for those people who signed up for the next one, I'll be talking about the EO index, which is a specific measure of calibration, or how close things are. So that'll be, and then the next one I'll be talking about logistic regression, which you can do both discrimination and calibration with that. So those are the next ones coming up. So I won't say much more about the statistical indicators at this point, but other than we'll talk about them in a bit. So what we'll do now is talk about some other criticisms to consider. And the main criticisms can be grouped into these categories. One is the quality of evidence. So if you're making a generalization for group data to an individual, how good is that group data? And there's a number of ways of looking at that. There's a second thing to consider, which is bias. And we're particularly concerned about bias towards already disadvantaged groups. So if you have a group that is in a disadvantaged position in the States or Canada, then we don't want to make it worse, essentially. And there is that potential. And the third is it fit for the purpose? Does the risk tool line up with the question that you're really interested in? Okay, and how do you look at this? Again, I'll go through these fairly quickly, but just give you some sense of the types of things that you should be considering, and I'll make some comments about the specific measures. Quality of research evidence. So you want large sample size. And when you're looking at sample size, what's most important is the number of events. Like if you're looking at sex offense recidivism, which is our area, it's the number of recidivists which makes the big difference, not the total sample size. So if you have 1,000 cases and 15 recidivists, you're not going to get reliable estimates. What you want is, you want 100 recidivists if you can get them. But it's the number of recidivists, it's the smallest of the recidivists or non-recidivists which make the difference. You want representative samples that are similar to the group that you're applying it to. You want replication. Actually, you require replication. Unless you have super large sample sizes, some of the stuff they do in the UK where they have 20,000 or 30,000 cases, you require replication. You need meta-analysis to summarize the results are important. Different research teams have different reputations. I like to think our reputation is pretty good, but it is something that you need to consider because sometimes you get things from certain teams. It's like, well, they always say things like that and nobody else does. So I'm not sure. Careful and appropriate statistical analyses. The static group for many years, I think we've done quite well on this because we actually double run all our analyses. So we have a process in place of once we get the findings paper sort of done, we get somebody else to do it all again. And so that's something which we've been, and quality control checks is built into the whole process. Beware of improbable and impossible findings. I know when the VRAG came out with the bin 9 had a 100% recidivism rate, and Grant was walking around saying 100% recidivist, 100. I say, give me a break, right? Yeah, they're high risk, and they may be higher than some threshold, but I don't believe it. And nobody replicated that. So, one-off findings, just be very, very careful. And I guess, some sense about research teams that don't learn. If you're doing an evidence-based practice or research practice, look for signs that people change as evidence advances. So I think on this one, I guess particularly with the static, I think the stable too, I think we've done pretty well. We're weaker with the acute. The acute has a couple of studies, but probably not as many as I'd like. But for the statics, or all the statics, including risk matrix, I think we're pretty good in terms of just the overall basic quality of research. Open science practices. I'm not sure if you're following this, but there's a concern about sort of making up findings after the fact. And this is sort of a risk. It's a real risk. I don't think it's super big in our area. We haven't done particularly well on this, so we don't do pre-registration. We do occasionally share data, but not as much as people would probably like, because most of the data that I have is owned by somebody else, frankly. So we don't do as much of this. This is probably we could do a little bit better, but beware of publication bias. There isn't, in the meta-analyses that have been done, we don't find publication bias, but it's a risk that people, very often people will report small correlations. And again, our concern with things like static and stable isn't zero effects. Like if we're down to, if we're wondering if it's zero, we should pack up and all go home. We're wondering if it's big enough to care about and big enough similar to what we expect. Anyway, I think we could probably do better, something to think about. Protection against overfitting. So there's two protections. One is replication, and I think the static group has done well, or SAARNA group has done well in replication. I would say coherent theoretical model, we're working on that. We've got some of the work, I think particularly that Sébastien Brulette-Allery has done, which looking at the constructs underneath it, there's a bit of construct validity work that we're doing, but we probably could do better. And I think that's one of the sort of basis for research for the, I guess, static, stable, acute, and I guess risk matrix as well. We try to minimize counterintuitive variables. We don't have any right now that I know about. And we also have been good about replication. So I think we have that replication, but I think we could do better in terms of our theoretical models. This goes with the understandable. Again, a coherent theoretical model, like we have like the stable items, if you look at them, you can sort of say, I think I know what these things mean and what I could do about them. But that's a bit of an intuitive, just unstructured professional judgment way of looking at them. There's a lot more research that we could do on looking at the sort of structure and coherence of that. It looks like from things that are coming down the pike, that if you look at the stable, it basically comes down to the two factors you almost always find, which is sexual deviance, sexual crime specific stuff, and antisociality. But trying to understand what those things in or try to break those up a bit more is, well, I guess we have more work to do. Explicit method of risk tool construction, I think we're pretty clear and fairly simple. We try to make decisions that are simple for people to follow. So make scoring rules as simple as possible. There's some which are much other, criticize other people who have, opaque algorithms. There's a number out there. We're not using those in SAARNA at this point, and I don't think we will. I don't think we'll start getting into complicated machine learning algorithms because I don't think the benefits outweigh the costs. Fair, unbiased. This is something else we could do better at. What you want is having the historically disadvantaged groups explicitly involved in the scale construction. Like they should be at the table when you're deciding which items to include and what the meaning of those items are. We haven't done this. What we've done is, the best we've done is sort of retrospectively check whether it's sort of working with different groups, but that's not really the way to incorporate cultural diversity. Cultural diversity should involve consultation and understanding of these different cultures. What we've found is that there is, it predicts in almost any group, but with the minority groups, the racialized minorities in Canada, US, Australia, New Zealand, it doesn't do quite as well. It does, and that's, I refer to static, stable. I can't say anything about acute. And it's something that I think we need to consider more. I guess coming back to the elegance of the, somebody had a chat question about empirical actuarial, that they're air theoretical. Yes and no. You want your tool to be predicting for the right reasons. So, so for example, if you had a college admission test, and one of the items on it was your parents' income. That item, I bet you, would be a good predictor of success in college. But it's not what you want as an item, because what you want is you want academic ability or something else being the construct. This came up quite a bit. If you look at test standards for jobs, there's a strong vocational interest blanks. I don't know if you remember that one was around, but it had a whole bunch of questions about what you like to do. And it's things like, you know, I like watching bullfights, or I like smoking cigars, or I like, you know, various things. And if your scores were a certain profile, they accurately predicted success in certain occupations like manager, lawyer, whatever, real estate developer, tycoon. The trouble is they are reinforcing existing biases. Things like I like smoking cigars was, you know, very class, older white men, right? And so if you want to live in a world of older white men, smoke a cigar, right? But that's not what we want. We want to have risk tools that predict, and it's for the right reasons, that we can sort of say things about them. Now, we can have a theoretical, we can, I mean, we do in some cases, but that's not what we want. And because we want to protect against predicting for the wrong reasons. Anyway, with ethnicity, I think that we've got some more work to do. I think that I know particularly things like the stable in Canada with the Indigenous people is something which it's being used. It predicts, but it doesn't have that convincing, you know, this is really working type of evidence for it. I think we're missing something, and I think this would be, I think some consultation with the groups would actually help there. Okay, comprehensive. Ideally, you'd cover all the things that you need to know, and based on a theoretical model. You never get it. What you mostly get is comprehensive, like you get most of them. But things you can watch out for is sometimes you have a small set of variables. You may have like 6 or 8 variables to start with, and you get down to 3. Chances are there's probably 20 other variables you should have considered. And if the rationale, there isn't a strong rationale, and the data looks like you're just choosing them from ones that are available, there's a risk that you're not catching the right things. I think with static, we originally could have been criticized for this. As it turned out, we got most of them. Like when we tried with static 2000 and with static 99, we used what we got. With static 2002, we thought through the variables, and it did a little bit better, but not a lot. We didn't end up with a big jump. Where you get the jump up is when you get different sources of information. And I think adding stable, for example, bumps it up, bumps up the predictive accuracy, because you get different types of information from there. Whereas I think we're doing, if you do the static stable acute combination, I think you're probably covering most of the bases. But, and I think as it turns out, static as a static measure actually does, either static measure does pretty well, but that was a little bit by chance. Fit for purpose. So you have to look at what the outcome is that you're assessing with the question, with the data collected. I won't say much more about that, except I guess it's important to look at what the sampling frame, who is it they're intended to be. And I think part of what we're doing with the routine versus high risk, high need helps a little bit in matching up the sampling frame for the decisions at hand. Again, we've tried to keep it simple. We haven't succeeded. We have a 100-page coding manual. And I know Annie was just sending me a question last night that I had to go, yeah, I think she's right, but I had to go check, and it took me more than a minute or two to figure out what the answer was. So there's always going to be exceptional cases, and we just have to, they're hopefully getting rare. So we're trying to keep it as simple as possible. The lesson, and I guess the lesson for all you static stable trainers, is as the DSP lesson. When you get things complicated, people have to be conscientious to make it work. If you don't have it conscientious, then things start to fall apart, right? So if you need, there's a burden. There's a burden that is created by more complicated, and typically you don't get that much more predictive accuracy by if you keep it simple, you might lose a few things around the edges, but if you have too many exceptions and nuances, you end up, the whole ship sinks, sort of falls over with its own weight. And that is my sort of summary. So any sort of questions?
Morning. It's ridiculously early, so this might be stupid, but one of the problems I have is that a lot of my colleagues seem to think that the risk assessment, the actuarials are giving you the risk assessment. So their entire risk assessment is static net, well, usually ISRS, but whatever the tool says 40%, so it's 40% and they're done.
Yeah.
What I sort of do is use the SPJ and encourage them to use their judgment to decide whether this estimate fits him. So basically it says 10% chance of recidivism. He has a 10% chance of recidivism. But what I want you to do is decide whether he's in the 10 or the 90 and use the SPJ to inform that. Is that remotely correct? Remotely,
but I wouldn't do exactly the same. There is, first of all, I agree that administering a static 99 is not the risk assessment. I'm fully with you there. There has to be another judgment about the applicability to this individual. And generally, the risk scale score is your best judgment, but you have to make that judgment. And I think one of the things we learned from the DSP study is we asked people for overrides, and the people who did the overrides always screwed it up. They included things that they'd already included. The override was always wrong or just random. It was just, but their original scores got better and better. If they had to think about it, their scoring got better for both their static and stable. And so we strongly encourage people to think about their assessment and the validity of the assessment, the consequences of the assessment. What I'm arguing today is that argument is partially to do with the person sitting in front of you, but it's also partially to do with the evidence base for your risk tool. And your line users probably aren't very good at reading that research. I want you guys to be. I want you guys to be good enough at reading the research that you can feel confident in making inferences about the people from it. Okay, Robin has a question. Let's see if I see that. Yeah. Robin, do you just want to say, are you still there? Or are you gone? Yeah.
Yeah, I'm here.
Yeah, just do you want to?
I spend a fair bit of time in court these days. And, you know, obviously most of my work is in the SVP realm where it's highly contentious and people are, you know, willing to say virtually anything. And, you know, it depends on how convincing you are as a speaker, not necessarily how convincing your evidence is. So, I mean, I find myself often, you know, saying, you know, if I was stuck on an island with one risk assessment tool, you know, that would be static 99R. But we shouldn't rely on that in and of itself, that there are other factors we also have to bring to bear. And I've been working, you know, pretty strongly here in Florida to get us to a point where we're using stable scores and not just stable as an SPJ. You know, lots of fight back in that realm as well. But I guess the ultimate end is that that it doesn't seem at times like there's a way we can win this. You know, aside from being the best speaker in the room.
Just out of curiosity, one of the original meaning of probability was credibility of the speaker.
Mhm.
So this is a highly probable speaker. That's how it was used. So
Yeah, and I think actually this, these sorts of short webinars you're doing, I think will provide us with a lot of very helpful information in terms of how to counter some of those arguments that sound really credible, but are not particularly. And I think all of us who spend time in court know that judges and juries glaze over as soon as you start talking about numbers. We have to put it in really understandable terms. We can't say 41.26%. We have to say 4 out of 10, or we have to find some other easier way to put it. I mean, I really like the, if you have 100 guys lined up against your wall, which guy is this guy most like? I mean, I find that a lot of judges and juries really resonate with that. So the less we can talk about sort of complicated numbers with decimals and, all sorts of other fancy formula, the easier it goes for us. But, again, I think you're absolutely right. Sometimes it goes back to whoever is the most powerful speaker and who's willing to say whatever is going to most appeal to the judge or the jury.
Yeah, sometimes that's the case. Thanks, Robin. Oh, okay, yeah. So this is from Sam. In New South Wales, we're working on an evidence bundle which would sit along our reports to help the courts understand the tools. Perhaps we could give a copy, probably should, copy my new book. But yeah, no, but I actually think that's a really good idea. I know I sometimes do that, but I don't trust it that much. I don't expect them to read that sort of stuff. But I do think it's worth, or we have a responsibility not to do good assessments, but also to communicate the scientific basis of the assessments that we do. And that these are, and I really support thinking of creative ways of doing that in effective ways.
Do you have a quick counter argument to the statement, low risk is not no risk? I assume it's an international problem, and our parole board simply will not release people because 5% is still too high.
Yeah, so my argument against low risk is no risk is I use references to groups that aren't subject to whatever it is that you're doing. So I use references to things like the rate of sexual offending among people with a criminal conviction but no sex offense history. So we have a number for that. We also have a number in some of my more recent stuff. I haven't published it yet. Andrew, that's a paper that we're working on that is looking at the rate of spontaneous out of the blue sexual offending for the general male population, like regardless of whether they have criminal history or not. And if you can get people into those ranges, you can say, this is no different from people who you're not considering to be, quote, sex offenders or not considering to be at high risk. So like if it's a parole decision, what's the rate of sexual reoffending among people with no sex offense history on parole? And I'm sure it's a number, and that it's not going to be tiny. It's going to be a real number. And you can say this guy's down into that range. He's not indistinguishable. And anyway, that's how I respond to that one. In the interest of time, thank you all for being here. Hope it was helpful. And we'll see many of you in a month or so. Okay, take care.